Go ahead and go over the homework here. For this first one up here about defining chemistry, you need two parts to make this a complete definition. What are the two pieces that you needed?
Properties matter.
Yeah, you need something about studying matter's properties. And what was the other part? And something about difference between the mass and the weight. Okay, so we can even go even further than just saying gravity, although that's definitely the right answer. We can just say location dependent. And what about the mass then? Location so it doesn't matter what your location is, your mass is your mass. Your weight is wholeheartedly determined as to where you are. If you're on Earth, you've got one mass. If you're in different places on Earth, one weight. If you're on Earth and you're in different places on Earth, like Death Valley or Denver, you have different weights, but again, your masses stay the same. If you leave the planet, then the mass again is still the same, but the weight definitely changes. How about this next one? What do we circle? All of them. All of them. 7 to the negative fourth is 1 divided by 7 4 times, and it's that 4.16 times 10 to the minus fourth, and that 0.000416, and 1 over 2401. Read it backwards.
Well, I was thinking about the one, but I was saying some trick question.
No, I read it really quickly, and I thought it was a interpretation.
Oh, gotcha. So math is a lot like English, the English language. How many different ways can you tell somebody to stop? Too many for us to, we could probably sit here for 5 minutes thinking up different ones. But regardless, math is the same way. So while technically you could give me any one of those answers if that's what you were trying to give me, and I'd have to give you credit for it, there are almost always better times to use each of these things, right? Like sometimes the number in the question is the best way to answer the question, and sometimes it's the one with scientific notation, and sometimes it's a fraction. So while they're all equally correct, sometimes you'd prefer to use one in a given situation over another. All right, so here's the density equation. If I'm going to rearrange that for volume, then my volume is going to be mass divided by its density, and then if I'm going to rearrange it for mass, it's going to be mass is equal to volume times the density. That's the extent of the algebra that we're going to get into. Just rearranging simple algebraic equations. We're not even going to mix addition and subtraction with multiplication and division. So not this term, but so it turns out to be pretty simple. How about an example of a pure substance? Sorry?
Salt? No?
So you telling me salt, I know exactly what you're saying. You're actually saying NaCl, and that's totally fine, NaCl. But what we're going to find out this quarter is, I'll give you a different question. Give me the name of a vehicle, and you say car back to me. Well, a vehicle, I'm like a Honda or like a Tesla or something like that. So what we're going to find out is there are actually thousands and thousands and thousands of salts. We just call one of them salt, which is kind of silly, but that's what we do. Probably because it's the one we come in contact with most often. Okay, so NaCl, that's definitely a pure substance. Got another one? Diamonds? Okay, so we can just say carbon in its crystalline structure. So that's a very poorly drawn, subscripted, parenthesized CR. which stands for crystalline. So carbon in its crystalline structure is diamond. If I would have gone, we're going to do this later, this set of notes, but like G would be carbon as a gas, or just as a solid, that's just carbon as a solid, that'd be like charcoal, something like that. Or we could even do GR, which is graphite. Lots of different versions for carbon. Any of those are totally fine. All right, how about a heterogeneous mixture? Wood? Sounds good to me. Sand? All right. How about homogeneous?
Milk.
Hopefully. What else we got? Soda? In the container, maybe? I don't know.
Carbonate, is that what you mean? Soda bicarbonate. I wanted to say milkshakes.
Yeah, milkshake's fine.
Oh.
That would work. I'm hesitant to write soda up here for what reason? But when she says soda to me, I think she's talking about like a Coke.
Yeah, I agree.
So why am I hesitant to say homogeneous for that? There's probably bubbles in it. Like unless I'm looking at like a stationary 2-liter bottle and I'm looking and there's no bubbles running through it, then that would be a homogeneous mixture. The moment I open it up and expose it to the atmosphere, the CO2 starts to come out. Or you could have said like flat cola. That would have been totally fine as well. It's just that when I look at, like here you go. This is carbonated water. Do you see the little bubbles in there? So I'm not going to call this a homogeneous mixture. And this is what a soda would do for us. If it were like, this is what 7-Up would look like. Okay, so wait, what are we writing here? Milkshake is fine. Okay, so color change. If I see something and there was something happened and I got a color change out of what was there, is that going to be chemical or physical? All right, that's probably going to be a chemical change. And you have an example of something that changes colors? Fireworks. Fireworks definitely change colors. I like that. Just any kind of fruit. If you were to cut open an apple, obviously it's going to turn brown on you, right? What if you were to cut open an apple and there wasn't any air where the apple was? It's not going to change color. Yeah, if you put it in lemon water, then the oxygen starts reacting with the lemon until there isn't any of that left, then it'll start reacting with the apple. All right, and then I'll look at those last two later.